All right, hello everyone. We're going to look at lesson 33, which is the mole. So, whenever we deal with atoms and molecules, things as small as that, there's such an insane amount of them that we would have to always talk in such massive numbers. It would just be impossible. Our math we do would just be numbers with zeros that fill up the entire page. It would be ridiculous. So, what we do to make counting atoms more practical, we use something called the mole, which is 6.022 times 10 to the 23rd. So anytime you say I have 1 mole of something, that means you have 6.022 times 10 to the 23rd. That's a lot of zeros at the end of that number. We call this Avogadro's number because a man named Avogadro first invented it, or first came up with it to count atoms. A lot of people just call him avocado because that's what it sounds like. The reason you haven't heard of a mole used towards anything else is because it's such a huge number, it doesn't apply to anything in the real world. Nobody has a mole of dollars or a mole of bricks. Nobody's ordering a mole donuts or anything like that. Like, mole is just a huge number that doesn't apply to anything else we would practically use. Atoms, though, are so small and there's so many of them, a mole is extremely helpful. Here's an example of what we would do. We would just say 1 mole of helium atoms instead of saying 6.022 times 10 to the 23rd atoms. Imagine writing this without scientific notation. That means you're going to move the decimal over 1, 2, 3, and then add 20 zeros and go 20 more times. Imagine writing that number every time. Instead, you can just say, I have a mole of helium atoms. It means you have this many helium atoms. Or a mole of water molecules. It means you have this many water molecules. So here's what the math is going to look like for this. And I'm going to do it, I guess you could say, the long way, but it's going to be necessary. So it says, how many atoms are in 4.5 mole sample of helium? So what it's saying is if I have 4.5 moles of helium, let's figure out how many atoms that will be. So 4.5 moles of helium. So the way you do this, whatever unit's on top, write that unit on bottom on the next one over. And then what you want to do is convert it into whatever unit your answer needs to be in. So now for this, you ignore this for a second. Moles of helium are how many atoms of helium? Well, the way it works is 1 mole of helium is 6.022 times 10 to the 23rd atoms of helium. Okay? So then what you do is you'll multiply everything that's on top, divide by whatever's on bottom. So when we do this, when we find the answer, first off, moles of helium, moles of helium. If a unit's on top and bottom, it cancels out. So our answer will be in atoms of helium. And then just multiply the top. So you could use a calculator like this if you have one. Your computer might have a calculator you can use, though since we're using these large numbers with all these decimals, it might be difficult. What I have open here, and you can use this, is this Desmos calculator. I like this. You just go to desmos.com/calculator, and here, let me redo this problem. So you'll see I'm going to do 4.5 times 6.022 times 10, and then I'm going to do this thing to go up to the 23rd. And it instantly figures out the answer right there. So we have 2.7, we'll call that 2.71 times 10 to the 24th atoms. Okay? So that's how many atoms. There's supposed to be a decimal right here, 2.71. So if you have 4.5 moles of helium, that'll be 2.71 times 10 to the 24th atoms of helium. Okay? So before we get to this next type of problem, I want you now to go on the lesson, and I want you to try to do the first. Let's do the first 4 questions. Go ahead and do the first 4 questions. So press pause, try the first 4 questions yourself, and then you can go ahead and press play. Okay, so when you do this, I'm not going to take time to do every single one of these problems. I will make sure that you're doing them right. 1 mole of hydrogen, you end up doing 1 mole times 6.022 times 10 to the 23rd. You end up with 6. This is your answer right here. Okay. You would set up what I have here, except for instead of a 4.5 right there, you'd have a 1. And so you'll just do 1 times 6.022 times 10 to the 23rd. For number 2, you'll have 2.5 moles of oxygen times 6.022 times 10 to the 23rd atoms of oxygen. So when you set it up, it should look like this. 2.5 moles times 6.022 times 10 to the 23rd. Pull up the Desmos thing. And so we have 2.5 times 6.022 times 10 to the 23rd. And we get 1.5, probably round it to 1, times 10 to the 24th. Okay, so it has the whole thing written out. 1.5055 times 10 to the 24th. Now for this one, we replace, so it's going to be, instead of a 2.5 moles of oxygen, I think, was that problem nitrogen? Nitrogen. So with this one, it's going to be, just for the sake of time here, I'm just going to leave everything but replace the only things that change. So it's 0.5 moles of nitrogen, and 6.022 times 10 to the 23rd atoms of nitrogen equals 1 mole of nitrogen. So now you're just going to do 0.5 times 6.022 times 10 to the 23rd. So go to Desmos, 0.5 times 6.022 times 10 to the 23rd. So 3.011. 3.011 times 10 to the 23rd. I hope this is starting to feel pretty straightforward for you. And then lastly, we do 0.0005. So for that, you know how it's going to work out. We're going to set it up the same way. So this time it'll be 0.0005 times 6.022 times 10 to the 23rd. So 3.011 times 10 to the 20. 3.011 times 10 to the 20. There we go. Okay, so now the next type of problem is going to be a little different. In this one, we discussed earlier that the mass of an atom is measured in what we call AMUs. So I need to go here. We're going to go to the support section, so closer to the top. And we're going to open up the periodic table and just have that handy. Periodic table of the elements, have that handy. So now what we're going to do, so it works out that a mass of an atom is measured in AMUs. So the mass of a hydrogen atom is 1.008 AMUs. But Avogadro's number, this is why he picked this number, works out. So that one single hydrogen is 1.008 AMUs, but a mole of hydrogen is 1.008 grams. Some periodic tables write it as 1.0078. But look, that number right there, the reason it doesn't say grams next to it is because it could be one of two things. If it's a single hydrogen, it's 1.008 AMUs. If it's a mole of hydrogens, it's 1.008 grams. So we're going to use that to go back and forth between mass if we need to. So what is the mass of 0.5 moles of helium? So when you need to find mass, what you'll do, you're going to look here and find helium. So this tells me 1 mole is 4.003 grams. Okay, 1 mole of helium is 4.003 grams. So when we need to find the mass of, I went all the way to the top of this. Let's go back to where we were. So when we want to find the mass of 0.5 moles of helium, it's going to look like this. So if it's 0.5 moles of helium, let's practice setting it up properly. Let's turn, now we're going to turn a mole of helium, and they want the mass. Mass is going to be measured in grams. 1 mole of helium is how many grams of helium. And how do we figure that out? By going here to our periodic table. I don't even have to minimize my screen. One helium is 4.003. So when we go back to what we were doing, 1 mole of helium is 4.003 grams. So you just do 0.5 times 4.003. So right here, we do 0.5 times 4.003, and we get 2.0015. So right here, the answer would be 2.0015, okay? So it's the same process for 5, 6, and 7. I want you to try to do 5, 6, and 7. So press pause. You try them yourself, see if you can get the answers, and then you can press play. Okay, so we have 2.0 moles of helium. 2.0 moles of helium. You know what? I'm going to set them all at once, and I'm going to do them all in one swipe. So 0.25 moles of oxygen, and then we have 4.0 moles of calcium. So if you look, I'm literally just doing all 3 problems at once because it's the same process for all of them. Okay? And we know for this one, we're going to go 1 mole of helium turns into how many grams of helium, and we'll look up the periodic table. For this one, we're going 1 mole of oxygen turns into how many grams of oxygen, and in this one, we're going to go 1 mole of calcium turns into how many grams of calcium. And so let's go to our periodic table. So I'm going to fill this out as I find them. So the first one is helium. We already looked at that. That's 4.003. So I'm going to write it up here. 4.003 grams. Oxygen is right here, 15.999. And then lastly, calcium, which is going to be over here, 40.078. So you see, we've set up all of our problems. So to find helium, we're going to do 2 times 4.003. To find oxygen, we're going to do 0.25 times 15.99. To do calcium, we'll do 4.0 times 40.078. All right, so let's do all those, and we'll get all of our answers. So we're going to do 2.0 times 4.003, 2.0 times 4.003. And then on our next one, we're going to do 0.25 times 15.999. And then for our last one, it is 4.0 times 40.078. See how simple it is when you know how to set them all up. So for number 5 right there, we have 8.006. 8.006. For the next one, it'll be 3.99975. So number 6, 3.999, they rounded it to 4, so there's our answer. And then for the last one, 160.312, 160.312. There we go. When you know how to set it up, it's straightforward and simple. This will get longer, more complicated, and as long as you're setting it up like this, you'll be able to stick with it even when it gets complicated. All right, have a good rest of your day, and as always, email me if you have any questions.